Do you want to create this from scratch using Houdini and Unreal Engine? A fully playable Colosseum, modular, procedural, and controllable with PCG. Project files available for download. My name is Mohamad Salame, technical artist at SideFX Labs, and this is an EPC workshop on Houdini and PCG. Now, before we get started, this workshop is based on a series of tutorials available on the SideFX website. You can find the link below. A quick recap. Copy to points. That's basically the whole workflow in Houdini and in PCG. We have a list of meshes and a point cloud feeding into a copy to points with a piece attribute to match each mesh to the desired point. Here are the meshes. These meshes are procedural. For example, this pillar is using a tube and boolean, curves, extrudes, VDBs, etc. And the material slots from groups is to assign multiple materials in Unreal. And this is the point cloud. Each mesh has a point ID attribute value. The copy to points is for visualization only. The point cloud and the meshes are what is needed for PCG. We can either export the point cloud using a CSV data table or Alembic. I'm not going to cover the CSV method in this workshop, as it was developed for Unreal 5.2 and 5.3. The recommended method is the Alembic, which exists in 5.4 and up. The Alembic ROP node exports the point cloud with attributes. Make sure your points have orient attribute for rotation and is normalized between 0 and 1. Scale by 100 to match the Unreal unit scale. Using a static mesh spawner in PCG, with a mesh selector type set to PCG mesh selected by attribute, allows us to match and set list of meshes to the point cloud based on a mesh ID piece attribute. We use data assets to store the list of meshes, create a struct with a static mesh and an integer, create a blueprint of type primary data asset, and finally create a data asset to hold the mesh path and the mesh ID. This is what the data asset looks like. It's a list of meshes with an integer corresponding to each mesh representing its mesh ID. The load Alembic reads the point cloud. Initialize the city sample setup to work with the Houdini transforms. When re-importing the point cloud using Alembic, you have to flush the cache. You can do that by holding Ctrl and force generate. Otherwise, nothing will update. This is the full node setup in Unreal PCG. Match and set attributes node is the same thing as copy to points in Houdini. You can copy static meshes to points and materials to static meshes. You can spawn actors as well. The data asset goes into a get property from object path node into match and set attribute node, matching the mesh ID between the point cloud and the list of meshes. You can override multiple materials per mesh if your meshes have more than one material. I used attribute rename to rename the first material slot so I don't have to create new struct for each material slot. Here's an example of material overrides. The pig is made of boxes and spheres. I used ambient occlusion SOP to calculate the gradient, then assigned darker materials to the darker areas and lighter materials to the lighter areas. You can swap your proxy meshes with the final version simply by updating the data asset. Here's a stylized foliage example using the same Houdini Alembic to Unreal PCG method. We all know these guys. Each one of these Lego pieces is an instance. It's not bad. PCG can handle many instances. Use an attribute to override materials, and multiple attributes for multiple materials per mesh. Because we are using Houdini, we can do Houdini things, such as turning a building into Lego. Using attribute filter, we can filter by mesh ID. Here's a fun example of filtering by attribute at runtime. This is a point cloud from the Matrix demo. A simple building meshes. And this is it in Unreal using PCG. Here is a roads example. You can draw them with a curve node in Houdini. And easily swap the data asset to switch between roads and pipes. Or if you want to spawn prefabs, you can use the same method to spawn actors instead of static meshes. Another PCG example using realistic assets. Here's a fun example, but it's too slow. I don't recommend animating PCG points anytime yet, but maybe in the future. Okay, back to our example file. Let's do some changes to this building. Feel free to follow along if you have the project files open. In Unreal, open the PCG graph and bypass the Alembic bake. We need the latest changes. Make sure your Alembic node is reading the correct file. Hold Ctrl to force generate Alembic changes. This is the data asset. You can see it's using s_id and not mesh_id for the piece attribute. I'll explain later. And the static mesh spawner is using mesh attribute for mesh path. Okay, let's up the difficulty and build a Colosseum. First, we look at the wrong way of doing things. The problem with modeling with nodes is that you don't know what node corresponds to what part of the building, and every time you want to edit that part, you have to go looking for the node in a giant node structure. It's really annoying. Is it this one? Is it this one? No, 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 no. Found it. And now I can do my edits. What if we make modules? And use an HDA with Python states to place the modules. Then create the Colosseum from there. Keeping in mind this HDA needs to output a point cloud and a list of meshes to export to PCG. I made 3 unique lanes, then bent them and instanced them. The problem with bending meshes is that they are narrower closer to the center and wider away from the center. So we need an additional variant attribute to keep track of the changes along the x-axis. So now we have a mesh ID and a variant ID, but the copy to points can only take one piece attribute. So how can we make the copy to points take more than one attribute with only one piece attribute? Any thoughts? A cool way of keeping track of variants alongside with mesh IDs is by concatenating the mesh IDs and the variant IDs in a string attribute, something like 1_1, 1_2, 1_3, etc. After bending, the list of meshes used are different from the original modules, so now we need to extract them without any duplicates. Then we use the extracted meshes and the point cloud with the concatenated string ID in the copy to points. Too many meshes to export manually. We can use a Python SOP to batch export them. With the for each loop, we can loop over all the meshes and trigger the Python SOP to press the button on the FBX output. We have a problem. We have way too many meshes to fill the data asset along with the string IDs, so we need a scriptable tool to autofill them all. This is how the meshes are named, so I can extract the string ID from the mesh name. This is the scriptable tool. It loops over the selected static meshes and assigns the meshes and their extracted string IDs to the data asset. To use the scriptable tool, right-click on the selected meshes and find it under the scriptable asset actions. You can select the data asset you want to fill. The start and end are extra characters before and after the string ID numbers. There's an auto-generate collision option too. This setup should be familiar by now. The only extra thing going on here is the save PCG data asset, which can be used to bake Alembic point cloud into an Unreal Native asset instead of having to load it from disk every time. Flush the cache by Ctrl-click to force generate. And we got everything in. Let's look at the cloth. I tried using splines for the ropes in Unreal at first, but the performance tanked, so I ended up making a small section and exported that as a static mesh. In this tutorial, you can learn how to export splines between Houdini and Unreal. PCG can read splines and it performs better than the standard way of spawning spline meshes with blueprints. But like I said, it was still not performant enough in the engine, so I used static meshes instead. First, get the points at the tip of each mesh on the Colosseum. Then make an inner ring and connect the points with a line. Subdivide the line and use a ramp to let it hang on the y-axis. Then we use those lines as a collision object for the vellum sim. Model simple grid, then run them through a vellum to hang on top of the lines. Once I'm happy with the result, I can copy them around. But I only need to export one of them, of course. Let's talk about Place Radial Geometry node. It can take multiple node paths, similar to the Object Merge node. Enter the state, hold Shift and left-click anywhere on the grid to spawn a new mesh. You can select a mesh by left-clicking once on it. Shift left-click on a mesh would duplicate it. Scroll to change the mesh ID. You can choose whether you want to bend the mesh or not. For example, the statue should not bend. The fourth output visualizes the final result. But you can always edit the layout. In the Settings tab, you can adjust the number of instances and the length of each lane, and other things. Each instance has a position data, a mesh ID, and rotation and scale that are controlled in the viewport with Python states. We have a problem. What if we placed hundreds of points and meshes, but then lost the HDA parameters? Well, we can always export the parameters using a JSON and then read from it This HDA can export and import JSONs. So I can simply load the Colosseum setup I had before into this HDA. Everything is looking correct. I'm gonna load a different JSON. And here are the outputs ready to be exported to Unreal. In Unreal, let's open the PCG graph. Press E to disable and enable nodes. Bypass the Alembic bake to get the latest updates from Houdini. It looks blue. Well, if we go back into Houdini and export the point cloud again, and force generate the graph, there. By changing the material integer value in Houdini, we can override materials in Unreal. Let's set it back to 0. You can plug your data asset into the parameters of the PCG graph settings. I also added float parameters to filter meshes by attributes. And you can edit them in the PCG graph instance in the level. Let's make some changes to the layout. Duplicate the banner. Delete a column by Ctrl left click. And export the Alembic. Oops, wrong material. Not a problem. We can find the mesh ID of the banner, which is 50 in this case. Then write an if statement that says, if the mesh ID is 50, I want the material to be a different number. Then the banner will use a different material from the data asset. As for the material, it's very simple. It's using world-aligned textures on some textures made with COPs. This is the Copernicus network. I wanted a painterly feel, so I started making a few brush strokes, then scattered them around. Then distorting them, dilating, feather, and a bit of ambient occlusion. I noticed I had to toggle row on the ROP image output because the normal map was too bright in Unreal. Toggling row fixed the gamma issue. Let's look at the brush strokes. A fractal noise to RGB, then back to mono to get a nice noise. Then dilate, distort, feather, over and over again until that smear smudge feel of the brushstroke is there. If you survived this far, I'm gonna dive into the Radial Geometry HDA. Here we go. First, we create points from the number of multiform entries, then get the values of each entry. The meshes are assigned mesh IDs to be used in a piece attribute on a copied points. Keeping in mind we already created a string ID on the points to keep track of the variance on the x-axis, which will be useful when we bend now. Here we extract the origins from each instance and bend the points and copy them radially. Okay, back to the meshes. Center the meshes and remove the duplicates. then only bend the meshes that have their bend toggle on. Finally, we can have the bent meshes and the bent points with the string ID to be able to copy radially in a clean modular way. The ISO attributes are the attributes we were using to filter by attributes in PCG. Under the Scripts tab, you can find the Python script for importing and exporting parameters with JSONs. And that's the callback script on the button to trigger these functions. Under the Interactive tab, you can find the Python state that allows viewport interactions. The workshop is over now. You can leave. I'm going to talk about Python states for a bit. These are the functions to trigger events in the viewport. On enter happens when you hit enter. On mouse event happens when you click left click. There is on picked and on active. On picked happens when you click once. On active will trigger as you drag the mouse in the viewport. So under on active, we place a new mesh on an invisible grid. We update the multi-parm entries and the position of the new mesh. On key transient event, you can trigger events with Ctrl and Shift. I'm changing an integer value if I hold or release Ctrl and Shift. And when I use left click mouse button with Ctrl or Shift, I can have extra functionalities. The intersect function needs geometry to intersect with. Then we get the prim of the intersected geometry. And since all of our meshes are packed, each mesh is basically one prim. Since each mesh is one prim and has a prim number, that number can directly correspond to the number of multi-parm entries, making it really easy to keep track of all the data needed per instance. If prim exists, we get the PTID, which is the multi-parm instance number in this case. Update the handles. If we're holding Ctrl, delete the mesh. If we're holding Shift, add a new mesh. Eval parm tuple to evaluate vectors, and eval parm to evaluate floats and integers. Parm and parm tuple get the attribute and then .set to set their new value. Return true to consume the event, otherwise nothing will happen. On mouse wheel event is triggered when you scroll the mouse. In this case, we are updating the mesh ID of the selected multi-parm entry to scroll through the list of meshes. And finally, we have a menu that pops up on right click and handles that read and write to the state. And that's it. I want to say thank you for SideFX and Breda for making this EPC workshop happen.